All right, good morning. All right, assignment 7.2 is due tonight. And I'm hoping to teach 7.4. So we're skipping 7.3 and I want to teach 7.4 today. But before we get started, the other day I worked a problem in your lesson 7.2. I think it was 24. It was actually a word problem where we set up a system in 3 variables. So I want to take questions on 7.2. If you want me to work any problems, we have time for me to work one, and then I'm going to teach part of 7.4. All right. Anybody want me to work any problems in 7.2?
Can you do number 9?
Sure. Actually, that was the problem they asked me to do last period. Yeah, so number 9. Let's do number 9. All right. So number 9 is 3x plus 2y minus 3z equals -2, and 2x minus 5y plus 2z equals -2 also. And then 4x minus 3y plus 4z equals 10. And somebody asked me the other day, they said, do you always pair up the middle one? And the answer is no. And the other question was, do you always eliminate a certain, like z? No. So you can pair them up any way you want, and you can eliminate any variable you want. The rule is, though, you have to eliminate the same variable in both pairs. So sometimes, well, I think one of the hardest things is figure out what variable should I eliminate. So when you look at this 3, 2, and 4, that does not seem nice to me. And then we look at 2, 5, and 3, that doesn't seem nice either. And z doesn't even look nice, but this 4 and 2 go together, and we have a negative, so I'm going to try to eliminate z. And I'm going to just repeat the second one. So I'm going to put the first one with the second one, and I'm going to eliminate z, which doesn't look super nice. And then I'm going to take the second one with the third one, and that doesn't look so bad because I just have to multiply the top by a -2. So just keep in mind, we want to eliminate z. So to eliminate z in the first one, and by the way, some people like to use one set of parentheses. The correct notation is a set of parentheses, a set of parentheses. So you're going to multiply the top by 2 because the key number is 6 here, common number. And you're going to multiply the bottom by 3. So remember, we're trying to get opposites for the z. So what we get here when you distribute is 6x plus 4y minus 6z equals -4, and 6x minus 15y plus 6z, so see the true opposites there, equals -6. And when you add, you get rid of the z, and that's what we wanted. So what we get is 12x, -15 and 4 is -11y, equals a -10. And so we come over to the second pair, and remember, we're eliminating z, so we're going to multiply the top by a -2 because we want -4. So we get -4x minus or plus 10y minus 4z equals a positive 4, and on the bottom, leave it alone. So look what happens here. The z goes away and the x goes away. So we're actually able to solve for y. So we get 7y is equal to 14, and when you divide by 7, you get 2. Well, this problem, which looked like a big mess, is actually going to turn out to be really nice, because can't we put y in over here and find x? So instead of setting up a system with two variables, we can find x right away. So we're going to take this 12x. I'll write it over here. 12x minus 11 times 2 is equal to negative 10. So we have 12x minus 22 is equal to negative 10. And if you add 22, you get 12. So x is equal to 1. So now, since we know x and y, we can find z by putting it back into one of these. So I'm just going to use this one because it has less negatives. So 4x minus 3y plus 4z equals 10. You're going to plug in the 1, so that's 4 times 1 minus 3 times 2, 1, plus 4z equals 10. So 4 times 1 is 4, minus 6, plus 4z equals 10. Combine those would be negative 2 plus 4z equals 10. Add 2. Add 2 would be 12. Divide by 4, divide by 4. So now we want to write an ordered triple. And the ordered triple is going to be x, y. That is the correct answer, by the way. So a couple things. See how I'm keeping my work organized, and see how I'm being very careful about things, because I don't want to make any mistakes because this problem is really long. So because we were able to solve for y right away, we just plugged y into this one to find x, and then we plug both of them back into one of these to find z. Does that help, Mark, or no?
Yeah.
All right, does anyone want me to do another problem or any questions about this one?
Can you do number 12? So in number 12, you have x plus z equals 3, x plus 2y minus z equals 1, and 2x minus y plus z equals 3. All right, so when you look at what the pairs, it's like, that doesn't look very good. That one, who knows, that's a 0 there. But see how the z's, I can put the first two together and the last two together? See how the z's are going to cancel? That's what I would do. So I would take x plus z equals 3 and pair it with x plus 2y minus z equals 1. And this is the one I'm reusing because of the negative. X plus 2y minus z equals 1. 2x minus y plus z. So it's easy to eliminate z. So when you add this, you get 1 plus 1 is 2x plus 2y equals 4. And over here, you get 2 plus 1 is 3x plus 2 minus 1 is y equals 4. And now you have a system in two variables. So you have 2x plus 2y equals 4. And you have 3x plus y equals 4. And you can use substitution or elimination, but I'm just going to multiply the bottom one by a -2. So I'm going to multiply the bottom one by a -2 and eliminate y. Watch your notation. So you should have two sets of parentheses, and you should put that in parentheses because you don't want it to look like 4 minus 2. Make sure you watch your notation. I don't want your future teachers to think I didn't teach you this. So two sets of parentheses, make sure you put that in parentheses. All right, so we have 2x plus 2y equals 4. You know what? You could have divided the top by 2. And that might have been easier. So you could divide the top by 2. It might have been easier. But I'm going to continue on here. -6x minus 2y equals -8. And I just eliminated y. So you get -4x is equal to a -4. And when you divide by a -4, x is equal to 1. So now you're going to plug that into one of the equations. I'm just going to plug it into the black one. So it'd be 3x plus y equals 4. So that'd be 3 times 1 plus y equals 4. 3 plus y equals 4. Y equals 1. And now, to find the third one, you're going to plug into one of these. Well, I don't know about you, but I like the top one. So the top one is x plus z equals 3. We know that x is 1. Oh, you know what we could have done? Once we found x is equal to 1, we could have plugged it in. So let me show you. There's a lot of different things you could do, but let me show you what you could have done. You could have plugged that x into the top one. So if you plugged it into the top one, you got x plus z equals 3. We know x is 1, and you can find z. So z is equal to 2. So to find y, you can't plug it into the top because there is no y in the top. So I'll pick the middle one. X plus 2y minus 2 equals 1. X is 1 plus 2y minus 2 times 2 equals 1. 1 plus 2y minus 4 equals 1. Combine like terms. Y minus 3 equals 1. 2y equals 4. Y equals 2. So your ordered triple is x, y, z. It should be 1, 1, 2. So my book's saying 1, 1, 2. So there's a mistake somewhere. So the x is okay. The y, let me check it. Oh, I didn't put it in. This should be x plus 2y minus z, not 2z. You guys aren't following me very close. Not helping me out. So be x plus 2y minus z equals 1. So if we plug x into the top one, we have x plus z equals 3. So x would be 1 plus z equals 3. Z equals 2. Plug it into the second one. So this would be x, which is 1, plus 2y minus 2 equals 1. So that would be 2y minus 1 equals 1. 2y equals 2. Y equals 1. So it should be x. So this is the correct answer. So I wrote this down wrong.
And this is a courtesy call to renew your warranty file. Interested in renewing your auto warranty now? 5 now. Or press 9 to be removed from our.
You guys follow that?
Yeah.
So like I told period 1, the reason why we're doing this is because I feel like you're weak with your algebra skills. And so hopefully this is really helping your algebra skills so that you can go transfer to the next class, your college class, with more training on algebra. Also, I hope this lesson is helping you appreciate to keep your work organized and be neat, because you don't want to be making mistakes. These problems are too long to keep making mistake after mistake after mistake. So it's requiring you to know about positive and negatives. It's requiring that you know how to distribute. You know, it's requiring you to really know what you're doing. Okay, so this 7-2 is due tonight. I want to get started on 7-4, because in 7-4, guess what? You're not solving a system of linear equations in 2 variables. You're not solving a system of linear equations in 3 variables. You're solving a nonlinear system. So what does that mean? That means if you have a quadratic and a line, it could miss the line completely. No solutions. If you have a quadratic and a line, it could cross once, which means one solution. If you have a quadratic and a line, it could cross twice, which means 2 solutions. And it gets worse than that. You could have a circle and a quadratic. So if you had a circle and a quadratic, you could have 3 solutions. If you had a circle and a quadratic, you could have 4 solutions. And the more the solutions, the harder the problem is. So we may not get into that, but we are going to look at nonlinear systems. So let's get started. This is lesson 7-4. And this is solving nonlinear systems. Nonlinear means they're not both lines.
Miss Birch, I'm not sure if it's just me, but your volume is really low today.
Yeah, I don't know how to fix that because I'm talking really loud. And I have my volume up, but unless somebody can help me, I don't know how to fix it. When I go to the bottom right, my volume is 100%. If anybody else knows, I'm looking at audio and video up at the top of my screen, and speaker and microphone settings. Yeah, see, I have everything maxed out. And so I don't really know. I don't know how to fix it. So if any of you have any ideas, just let me know. I don't know how to fix the problem, so. All right, so the first thing is you want to be able to recognize what you have. And I've been trying really hard since the beginning of the year to get you to look at something and say, is a line a quadratic? Is it a cubic? Is it absolute value? What does it look like? So let's just see if you can tell me. You see this second equation? Do you recognize that? What is it? What do you think it is?
Is it a straight line?
The line. Yeah, good, good, good. Okay, now, the guy on the top has 1 square. What kind of function do you know that has 1 square?
Quadratic?
Yep, good, 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 good. So now you're thinking, hey, I got a quadratic and a line, so what could possibly happen here? Well, like I said, a quadratic could misalign completely, no solutions. A quadratic could cross the line once, 1 solution, or a quadratic could cross the line twice. Can a quadratic cross the line 3 times? Can a line cross the quadratic 3 times? Can a line cross a quadratic 3 times?
No.
No. So when you work in a minute, when you work a problem like this, you're either going to have no solutions, 1 solution, or 2 solutions. And the more solutions, the more work. Let's go to this one. Do you recognize what you have here? So what's the top one?
A quadratic?
Right. So the top one is a quadratic. Now the bottom one, we haven't studied or even looked at very much, but let me just explain this, okay? Hey, listen, I'm going to throw some geometry in here. Okay.
When you have two squares and they look perfect like that, see the 2, 2, 7, 7, 1, 11, 1, 11, when they look perfect, it's a circle. When you have something that's almost perfect, that's not perfect. See how you have a 2 and a 3 with two squares, a 7 and 11? This is something called an ellipse. It's not called an eclipse. It's called an ellipse. So let me just say this. It's hard to be a circle. A circle has all its points equidistant from the center. It's hard to be a circle. So let me just say this. A circle is an ellipse, but an ellipse is not a circle. So just like the square. Hard to be a square. You have to have 4 equal sides and 4 equal angles. A square is a rectangle, but a rectangle is not a square. So just remember, a circle has to be perfect. And so when you look at this and you see a 1x squared and a 1y squared, that's a circle. That's all I want you to know. Okay? We're not going to worry about anything else. We're not going to worry about the ellipse or I just want you to know that when you have two squares and you have the same coefficients, 1, 1, 7, 7, 9, 9, 12, 12, it's a circle. So what's going on here? Well, this guy's a circle. So what can happen with a quadratic and a circle? A quadratic can miss the circle completely, no solutions. A quadratic could hit a circle once, one solution. And when I say I'm talking about one ordered pair. A quadratic and a circle could cross twice, two solutions. A quadratic and a circle could cross 3 times, and a quadratic and a circle could cross 4 times, 4 solutions. That would be a horrible problem. So that problem right there, we probably won't do, but that problem is it's a rough problem because you have to find possibly 4 solutions. Okay, let's talk about the solutions. For nonlinear systems, you could have a solution or a solution set. And what these guys are, this is going to be an ordered pair or pairs of ordered pairs of real numbers that satisfy both equations in the system. So remember in 7-1 where we had to test the ordered pair and make sure it worked in both? That's what this is saying. It has to work in both equations. All right, let's take a look at a problem. All right, here's my recommendation. Get an idea about what you have. So what do you have here? What are these? What's the first one?
A quadratic.
What's the second one?
A line.
So here we go. What can a quadratic and a line do? Well, a quadratic can miss the line, no solutions. A quadratic and a line could cross once, one solution. A quadratic and a line could cross twice, two solutions. Okay. So now we decide, do you want to solve by adding or do you want to solve by substitution? And I'm just going to tell you what I would do. Since there's a y, I'm going to use substitution. So I'm going to write them side by side. So you have x squared equals 2y plus 10, and you have 3x minus y equals 9. And I'm going to solve for y. So when you subtract 3x, get that. And when you multiply by a negative, multiply by a negative, and multiply by a negative, you're going to substitute that in for y. You're going to take this and substitute in for y. So we have x squared plus 2, x squared equals 2 times the quantity 3x minus 9 plus 10. Now, you're going to put this in parentheses, right? Because it's going to be 2 times that quantity, right?
Yes.
Right, Angel, Andres, Cynthia, Jaden, Naomi?
Yeah.
Yeah.
2 times the quantity?
Yeah.
Yeah? Jerry, Naomi, everybody else, Cynthia? All right. Now, I don't know if you noticed this, but you have a quadratic, which means you're going to have to use one of the quadratic solving methods. So guess what? Thought factoring went away. You're going to have to factor. And you just want to pray you can factor, because if you can't factor, you're going to have to use the quadratic formula, which is 9 steps. So here we go. So you're going to distribute, and you get 6x minus 18 plus 10, simplify, 6x minus 8. Now, remember to factor, we have to set it equal to 0, and I'm going to put everything on the left because I want my leading coefficient to be positive. Remember? I want my leading coefficient to be positive 1. So you're going to subtract 6x from both sides. You're going to add 8 to both sides, and you're going to set it equal to 0 and pray you can factor. So what multiplies to give 8 and adds to give negative 6?
2 and 4.
2 and 4. And they're both negative. So it worked. So what are your x's?
2 and 4.
So you know what that means, right? You have this situation, and you're going to have to find the y that goes with him, and you're going to have to find the y that goes with him. So you're going to find 2 ordered pairs. So here we go. So we're going to go back here, and we get, for x equals 2, we have y equals 3x minus 9. And for x equals 4, we have y equals. So instead of substituting into it once, we have to put both the x's in there and find the y's who go with their ordered pairs. So here we go. So put a 2 in. So you have y is equal to 6 minus 9, so y is equal to negative 3. So your ordered pair is right 2, down 3. That's one solution. And put a 4 in.
would be 12 minus 9, which is 3. So that would be right 4 up 3. And what I would do, I would write them in a solution set. So the first one is right 2 down 3, and the second one is right 4 up 3. And those ordered pairs are your solution. So once again, I solved this using substitution. And unfortunately, we had a quadratic, which caused us to find 2 x's. With substitution, remember you have to go back and substitute in here. Well, you had to substitute twice. So you had to find the y that went with this x, and you had to find the y that went with 4, which was 3. Let's do another one real quick. Questions about this? At least we're having fun, right? A lot of you never dreamed you could do math, and now some of you are thinking, hey, math isn't so bad. I mean, it's hard, but you can do it. Some of you are realizing, yeah, I can't miss her class. This is tough stuff. Some of you are realizing, wow, you know, all these things are building on each other, and you got to remember a lot of things. All right. This is a line. This guy, these numbers out in front of the square are perfect. That right there is a circle that has a center somewhere other than the origin. So the center of this circle is right 2 down 3. But it is perfect because the numbers in front are ones. So this is a circle. So what can a line do to a circle? Let's look. A line can miss the circle. A line could cross the circle once. A line could cross the circle twice. It cannot cross it 3 times. So once again, I'm going to use substitution because I can solve for x or y. So I'm just going to solve for x here. So remember, you can solve for either variable. And I don't want to solve for y because it has a negative. So I'm just going to add y to both sides. And I'm going to substitute that in for x. So I'm going to put this in for x. So what you get here is you get y plus 3 minus 2 quantity squared plus, and this is going to be a FOIL, y plus 3 times y plus 3 equals 4. So this is going to be y plus 1 quantity squared, and you're going to have to FOIL that. This is going to be first outer inner last FOIL. This is going to be a FOIL. First, outer, inner, last. A lot of work. Combine like terms. Y plus Y is 2Y. 2 plus 6 is 8Y. 2Y squared. This is 8Y. And then 1 plus 9 is 10 equals 4. You have a quadratic, so you know you're going to have to set it equal to 0. So 2y squared plus 8y, subtract 4 from both sides. And now, look at, I can divide by 2. Divide by 2, divide by 2, divide by 2, divide by 2. And now we pray, we can factor. So what multiplies to give 3 and adds to give 4?
1 and 3.
Yes. So your x's are -3. I'm sorry, your y's, not your x's. Y's are -3 and -1. And you're going to have to substitute back over here. So I'm going to take x equals y plus 3 and x equals y plus 3. And we're going to have y equals -3 and y equals -1. So when you substitute in for y, you get x is equal to -3 plus 3 is 0. So that's going to be 0 down 3. And this is going to be x is equal to -1 plus 3, which is x is equal to 2, which is 2, -1. So make sure you write them as ordered pairs. These are correct, by the way. So your solutions are, it's this case right here. You're going to have 0 down 3 for one of the solutions, and the other solution is the point 2. So a lot of work right here because you had to solve for y and you had to FOIL and get everything broken down so you could factor and solve for y. All right, so I'm going to stop there today, and remember that 11-2 is due tonight. And anybody want to ask me about anything here?
So when you plug in the x or the y's, you use the same equation, right?
You use this one over here. Remember with substitution, we substitute this in over here, but then whatever you get, you have to go back here and substitute in, remember?
Oh, okay.
So remember we solve for y, and then you have to go back here and find x.
Okay. Thank you.
You see what I'm saying though, right, Mark? You see I went back here and I wrote it over here.
Yeah, I see what you mean.
Okay. All right, you guys, class is over. I hope you have a wonderful day. All right. And I'll see you tomorrow. Have a great day, okay? All right. Bye, guys. Have a good day.